Yep.
Cool. Is there anybody here yet?
Yes, a couple people.
Cool. All right, we're going to get started right away. I'm not waiting for people. I have been doing carbon fiber tests. Carbon fiber composite work has a huge amount of variables, so there's a lot that you have to learn to actually make carbon fiber parts well. It's really strong no matter what, but getting all of your process and all of the variables down so that you can make really good parts is actually pretty difficult. So I have 12 different tests that I kept here. I made 4 by 4 inch squares, and then I cut these whatever width panels. They're all exactly the same width. They were ground to the same size together. They're all exactly the same size. These are going to be for bend breakage tests to test the bend strength. And then I have these little guys here. And I ran a couple preliminary tests because we didn't know how difficult it would be to break these in tension. So you can see they're filed down to, I believe it's just under an eighth. Yeah, just under an eighth of an inch across in that little tiny gap right there where there's carbon fiber left. Because when we started pulling on this, looked up the math on it, and it would have actually taken like 20,000 pounds to break it, or something insane like that. So, had to make the amount that I'm going to tension test far, far smaller, and you'll see how much strength this still has, even with that little tiny minuscule amount of carbon fiber right there. So, without further ado, let's do some bend tests. Oh, and you're going to see weird numbers and letters on this stuff. It's all just reference stuff for me to remember what type of setup I did and what the result was. And the 3 tests that I'm going to do on this live stream are going to be the same pieces of carbon fiber for both tests. And it's the lightest sample that I made, the one that I think turned out the best after I got some guidance, and then the heaviest one. So lightest, heaviest, best, hopefully. We'll find out which one wins. But I'm excited to do the heaviest one, so that's the one that we're going to do first. And this little rig is something I just came up with. Actually, I can't set that there yet. I don't have a professional setup to test this stuff, but as long as everything is consistent and the same between breaking each piece, it will give me an idea of which setup I'm using is the strongest or the best for the different applications that I'm going to be using carbon fiber for in the future, as well as the buster swords. So this is basically just a little leverage setup. I have this hardened piece of rebar on top of the carbon fiber. I'm going to pull it down through the bars of this table. The zip ties are here to catch the rebar and the scale because that's connected underneath. Come on down. So I have a scale here that will, it's a crane scale that will give me how much force it takes to break this piece of carbon fiber. So basically, I just make sure everything's lined up. It's torn to 0. And that's lined up with the scale. I'm trying to pull straight down as accurately as possible. And then I need to make sure that my string on the top, I didn't do this before, is in the same place. And then my tape on this is a guide for where it's supposed to sit on the carbon fiber, and then I have marks for the carbon fiber, and I have marks for the bar. That way it's as even as I can get it, even though this looks super janky, it should be consistent. So now, all I have to do is leverage down on this. So it already has 10 pounds of force on it, and it's not bending at all. So I'll put some force on it. Go ahead and show the scale a little bit. So like it's already at, there's 50 pounds of force and nothing's really happening. But you're gonna get to watch it break, and I have another camera running that we're gonna get the final weight from this at. Move back up. And I'm gonna push down this bar really slow. It's climbing.
How many pounds are we at?
150. 200, 225, 230, 240, 250. My lever slid. It's too much. All right, I'm gonna have to move this out a tiny bit. It was still going up. You could hear the cracking of some of the fibers breaking. When these fibers break, they have such high tensile strength you can hear tiny cracks from individual fibers. So I'm going to move this back that way. I'm wedged up against this support in the table. And maybe I'll be able to get this to go without breaking the string. Nope. I didn't account for this. This is very strong. Clamps. Okay, so that's there. We'll put that right there. And there's leverage, so obviously I don't weigh 250 pounds. I won't be able to do that. That's why I have this lever system set up. Did this shift at all? Tiny bit. Okay. Here we go. Now it should be good, as long as my 550 cord doesn't break. $125, $130. I may have weakened it because it's making more noise. It looked like it was at 142, but it went to, I think it was 250 previously. Here, you can see, well, you might not be able to see. You have to look at this pretty close, but there's varying thickness in this. This was the heaviest because I wasn't very quick when I set this up. The resin was starting to set up on some of the bottom layers, and I didn't put that much vacuum on it. So it's thicker. So this should have really high bend strength, because if the layers are further apart, you have more leverage pulling on the fibers, where if it's really thin, or sorry, you have less leverage on the fibers. If it's very thin, the fibers are really close together. It's the outer layers that keep it from bending. The inner layers just act under, well, the bottom layer acts under compression. You know what I mean. The part that's towards the inside of the curve is being compressed. The outer one, it's the tension of that layer that's mostly doing it. So the further apart those two are, the more leverage it has and the more force it takes to break the piece. So it's not surprising that this did very well as far as bending is concerned. But let's see how much different it is for the skinny ones that are lightweight. And let's go straight from the heaviest to the lightest.
Do you have a number on that one? Give a weight.
Whenever it ended up snapping, it was at 142.
But it got
Okay.
higher.
Had
It
gone
got higher
previously, so
Right.
because you weakened it.
Did you
put
see
a-
what the highest one was before that?
181, I believe, was the
I
highest.
thought it went over 200.
The first time you pulled on it.
Yeah.
But
What
then
was
the
the
second-
highest? What was the highest on the first one?
We'd have to.
Since the test didn't work out perfectly, we'll just go with that one. I might need to put new string on this. This is getting pretty stretched. Actually,
I can review.
I'll tie a knot in it. Holy cow! I made that really tight. String needs shortened. Shorten it up just a bit. Come on. Get in there. Oh, this might be a problem. The 550 cord is stretching out like crazy. I'll put blocks underneath that, and we'll just keep going until the 550 cord breaks. All right. lightest.
Well, we're all about breaking things, so.
And we're gonna break everything. All of it. It's all getting broken. Okay. That's good. Yeah, I should have enough. I should have enough leverage. I figured 2 strands of 550 cord would be plenty for this because, I mean, it's 550 cord, and the scale is only rated for 660 pounds, so I can't exceed that on this test or the other one. All right, I'm ready. This is all set.
Let's do it.
Time for a break. Oh, let's make sure the scale's torn correctly. Yep. You ready? 40, 50, 60, 70, 70, 71, 70, 80, almost 80. Ooh, I hit 80. Far weaker because this is so much different. Actually, hold on just a moment. The lightest piece was 1.12 millimeters thick. And this point, and the heaviest one, is 2.21 millimeters thick. So a significant difference in thickness. Even though, same materials, same orientation, same amount of layers. Everything's identical. It's just the setup for making this can cause that much difference in the properties of the sheet. Which is why I have to test this stuff to figure out what to do to make my parts as good as I can get them. Third one. This is the one that I think it did the best. So, I hope this is also very, very thin. Like the other one. Yeah, this is 1.2 millimeters also. Except it's extremely flat and even. Yep, 1.2. 1.25. 1 on that end. If I go a little further in, it's 1.2. So it's very even, it's very flat. I hope this one does better than the light one that just broke it. How many pounds?
80.2?
80.2 was the final.
So if I can beat 80.2 pounds, I might have a winner for lightest weight. Yeah. There you go. Centered on the panel. I can already feel this one flexing. Can you see that in the camera?
I don't see much.
It's
Not in
already,
the camera.
It's already flexed off of
Yeah.
the steel just from the weight of the thing hanging from it. All right. Torn to 0 pounds. Right? Correct? Yes. It's zeroed. I'm lined up. That's still lined up. Here we go. 25, 30, 38, 46, 55-ish, 60, 72, 85, 90, 100, 114. Somewhere around 114 is how strong this was. The last one was 80. So this is thinner it weighed only 1/10 of a gram more than the other one. All the weights were in when I made the actual 4-inch square, when they were still even and identical like that. That's when I took the weights of all of them. So that's what I'm basing them on. But this was 1/10 of a gram more than the other one. Significant increase in strength. Same thickness. So that just shows you how much difference it can make just setup. And there's so many things that can change in doing that. That's why I'm doing this test. So if I need something light, this is the way to go. If I need something that's able to resist bending like crazy, I need to oversaturate it with resin, not pull much vacuum on it. Now, it's on to the serious test. That was the lightweight stuff. Now we're going to get to the real scary, high weight, super high amounts of force, craziness, by just doing these little tiny pieces here. It's going to be an unbelievable difference in the amount of weight. Come on.
The highest number on that last test was 115.9.
115.9? I thought I hit like 120. No?
Not that I saw.
Cool. I mean, that's still significantly higher.
Yeah.
Yeah, because the last one was 80, so that means it was 30 pounds higher, which would be whatever percent more. 40, 30 something, 40% more-ish? Somewhere in there. Doesn't matter. I have to undo this rig to set up the next rig. Actually, let me move the table. Oh.
Move that table.
I'm going quick.
Got set change.
I actually need this. 100%. When I did a test earlier, before I notched the pieces, I pulled a piece out of the vise and I was almost at 800 pounds and it overloaded the scale and it pulled it out of the jaws of the vise and it didn't make a single noise, nothing. It just slipped out like it was greased. And that's when we looked it up and found out that it would be tens of thousands or hundreds of thousands of pounds to pull out the entire piece. I think it was tens of thousands. It was a lot. It was an outrageous amount. There's some reasons that this won't line up at all with the tensile strength of carbon fiber, which is 500,000 psi? So that's like for a square inch of nothing but carbon fiber. So this has strands going all different directions. It's 45, negative 45, 0, 90, and then a 2x2 bias, and the other ones are unwoven. So this only has technically 3 layers of fiber going exactly in the direction of the tension, plus it's infused with resin, so not all of the volume there is of carbon fiber. So it'll be much lower than that, but it's still going to be a huge amount of weight to break something so incredibly tiny. Actually, if I can, I might see if I can get a little piece of steel that's approximately the same width as this and try to yank that apart and see what the difference is there. If I can find one real fast and clamp it for you guys. Has anybody had any questions so far? Good. That means I'm explaining stuff right, I guess.
Yeah. Looks like we got 76 people watching and 44 likes.
Cool. Not as good as the last one, but the algorithm tends to screw me lately, so that's to be expected. Okay. Now, I need my hook. Thank you. So it took some time. I had to make this rig and set this up on here perfectly in line with that when it's about level. That way it's pulling almost perfectly vertically and it's not trying to bend the carbon fiber at all. I want to pull straight tension on it. And this was the best thing I could come up with right now.
There are a few people asking, what is this for?
So this is for future sword builds. I'm going to make more composite swords, increasing in difficulty, complexity, and functionality, and awesomeness and size and everything. But that, and I need this for the Aquaman build that I'm doing, because there's going to be a bunch of carbon fiber work on that. I'm trying to make sure this is level right now before I clamp this piece of carbon fiber into the vise, which I can now do. Tear the scale. Make sure that's straight. Nice and tight. Okay. I'm going to try to pump this as slow as I can, but the tension builds up very quickly. Ready? Where are we at?
34.
I'm going to stay on target. Call out the numbers for me.
52.
For me, at least.
55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 112, 125, 136, 150, 163, 187, 215.
Cool. That went up quick. I gotta get a new pump.
Yeah, this is all measured in pounds.
Where are we at now?
250, 260, 270, 290, 30, 312, 315,
I hear it. Can you hear it?
Yeah.
325, 340.
Woo! That was a powerful one.
It definitely startles you when it goes.
Okay, so you can see that was that much carbon fiber, and you have to remember that only 3 layers had fibers actually going in the direction that it was pulling. The rest were 45s.
There's flies everywhere. That's why he's swinging his hand.
Yeah, it's farm country. So yeah, that's hand for scale. Final.
342.9.
342.9 pounds for that right there. That means that I could pick up the motor out of my truck with that much carbon fiber. That isn't even all going the right direction. That's pretty impressive. Anyway, time for the next one.
Yeah, sorry everybody. Headphone warnings. It might get really loud when it breaks. It definitely made me jump.
Oh yeah, I thought we'd hear a little bit of cracking before it finally went, and it did not. It just went. By the way, that was the heaviest weight. That was the highest weight one. Started with that just like I did on the bend test.
So, prolific invention had a comment, you can cut down on weight greatly and still have a durable edge, even made from a thinner metal of a higher grade.
Is he talking about the metal of the sword?
I believe so.
Okay. Yeah, I mean the plan is to switch from titanium. Titanium is hardenable. Everybody says it doesn't hold an edge. It doesn't as well as tool steel, but it does hold an edge. Trust me, that I can still cut paper with the sword that I used in my videos, and I haven't sharpened it since all that stuff that I did. But yeah, the plan for the future is going to use different stuff. I don't want to give any away. I don't want to give away a bunch of the things that I'm going to do. I've seen videos on composite swords now, and I think it might start to become a thing. So I'm not saying that I have trade secrets because I'm just starting to do this, but I want to be the first one to do all the awesome stuff. Because otherwise people will say that I'm a copycat, even if I came up with the idea. That's just how the internet works. This is real scientific how much I'm torquing this. I'm just like looking at the gap and seeing how much the socket turns. That's probably tight enough. This is the lightest one, by the way. Hook's already on there.
Which material is this one?
This is the lightest one, so not the best one. When we did the heaviest, now we're doing the lightest, and then we're going to do the one that I thought turned out the best. To the same point that I was on the last one, and make sure this is even. I need to be right in line.
Okay, I'll move and try not to trip over cords.
Okay. I hope the scale isn't messed up. It's tearing correctly, but every time one of these pieces of carbon fiber breaks, it switches the units that it's on from pounds to kilograms. Pretty sure that's not a feature, but a flaw. All right, ready?
We're at 100.
Oh, yeah.
202, 220, 240,
Going quick.
270,
I hear it.
280, 290, 300, 310, 320, 330, 340, 350, 360, 370, 380, 390, 400, 410,
Woo!
The lightest piece. That's a pretty significant difference. I honestly didn't see that coming. I figured that these would be stronger in tension, but not by that much. I thought it would be some, but I guess the extra resin that's in there has the, if there's bends in the carbon fiber, it's not as strong if it's bent. That is kind of crazy strong. And then look at the thickness on it. I mean, that is just so tiny. It's kind of wild that that's that strong. What was it?
417.5.
That's insane. All right, now the one that I think laid up the best. So hopefully this one does better than the rest. Better than all the rest. It's like a truck commercial, isn't it? Simply the best.
Simply the best.
Better than all the rest.
Better than all the rest.
I don't know what truck commercial it is, but Chevy?
Chevy.
Like a rock. Eyeballing it for alignment. Make sure it's reasonably close. Looks pretty even. I think this one needs to go a tiny bit more. These are metric grade 8.8 bolts, or class, I guess they call them class 8.8. So this, the hardware they're using is pretty tough. Yeah, switch back to pounds again. It's a change time zone. Just being wonky. Doesn't look fun. It's hard to tell if it's lined up because the bevels that I cut, it was difficult to make little tiny cuts that were very accurate that got down to a really tiny little cross section. So in doing so, they ended up being off because I cut into it with a Dremel, and the you know, the body of the Dremel's in the way, so the blade had to go in at an angle. So tried to make them as accurate as I could, but it's difficult to get that lined up. It's hard to tell where it's actually at. Oh, you know what? I forgot to drop this. I did it on the last one. I didn't do it on this one, so I'm gonna have to reset it. But whoo.
People want to know if you leveled the lift prior to doing this.
I didn't level the lift. Or if you mean the lift arm, yes, I have a level right here, and I'm checking the level to make sure it's exactly the same spot every time when I go to start. That way it's all exactly the same place.
And it also looks like people are taking bets on when this one will break. So, do you have a prediction?
What was the last one?
The last one was 417.5.
I'm hoping this one beats 420 then.
The current bet is 470.
Nice.
470.
470, that's high. I'd be ecstatic if that went there, because that would mean I've got my system down for laying this stuff up, but I mean, if it's repeatable. We'll have to wait and find out, though.
I like that one. 420.69.
There was 2 decimal points. All right, here we go. Stop wiggling. Is it good? You filming?
Yep.
Okay.
70, 90, 110, 130, 150, 160, 180, 190, 200, 220, not quite, 240, 250, 260, 270, 280, 290, 310, 320, 330, 350,
It's gonna go.
375,
I hear it.
380, 390.
Woo!
So this one didn't do as well, but tell you what. Okay. So here's one thing that would cause a difference. I don't know if you'll be able to see this, but the top layer has the vertical strands like this. And this one has 3 strands that are going through the area that's cut, but the 2 strands on the sides are very small. So you have 1 solid strand in the center, but then you have 2 gaps. And when I looked at the last one, this one, this one, no, this one. This one, the cut came directly up to a gap, and then there's only 1 gap in the center, and then the next toe. So this almost had 2 full toes in it, and this one had 2 breaks. So right there, because that layer that you're looking at is 3K carbon fiber, which means there's 3,000 strands per toe, or each line that's woven is 3,000 different strands of carbon fiber in it. So that means that tiny, insignificant gap could be 200 threads of carbon fiber that would make a significant difference in the strength of this piece versus this piece. Obviously, I can't pull the layers apart to see if the other one's lined up really well or not, but that's unfortunate, especially because I thought this one was junk. I thought I messed up when I laid this one up, but it looks like that weight level might be pretty good. I do have a lot of other weight levels that I need to test, so there might be one that works better as far as the tensile strength of this is concerned, but I will have to wait and find out when I do more of them. But I don't want this live stream to go on all night long, because it's going to take some time to get all the rest of these tests done and write down all of the numbers and see which way I should be doing this. So, I mean, I'm not going to right now. If you got any questions, I can answer them. We were all wrong on our bets. Did anybody guess low?
The lowest was 381. So
What was the final weight that I got on this one?
394.
394.5.
Oh.
So
Pretty close.
if we're playing Price is Right rules, he wins.
There you go. You won.
I wanted the 420.69.
This stuff is pretty cool. It's kind of unbelievable how strong it is in certain ways. Some of the other sorts that I'm going to make, I'm not necessarily doing carbon fiber, but there's a lot of other composites that are out there that have incredible properties to them besides carbon fiber. Carbon fiber is extremely rigid and has stupid high tensile strength, which is really cool. But yeah, fiberglass is far more flexible, so if you need something that's flexible, fiberglass is the way to go, not carbon fiber. There's even stuff called S-glass that's almost, it's like so close to being as strong as carbon fiber, but it's as flexible as regular fiberglass. But that stuff is also extremely expensive by comparison to regular fiberglass. Go.
Angelo wants to know when to expect the next video.
I have to go out of town to see family coming up here soon, and I've been working on the next video, but I've had like 7 other projects that I've been working on at the same time. So it won't be this Sunday. It'll be I think it'll be next Sunday. I'll have to skip a week again. Everything's been coming to a head with a lot of different things recently, and I haven't had time to get all of the things done that I have to get done, and certain things are taking priority, so it's kind of been rough. I've been working a lot, and it seems like I'm not getting anything accomplished. But I'm still working on the projects. I haven't been able to get content made, though, because I have other things that actually, it's just life things that I've put off that take priority right now. It's unfortunate, but that's just the way it is. Yeah, so not this coming Sunday, but next one. Which is why I did this live stream today, because I didn't want to go that long without a video again. Yeah. You can get wood to do composites with too. Not wood, linen. It's like just plant fibers. And it's, I think it might be the lightest weight composite. Or it has higher strength to weight than other composites. I don't know if it has the highest strength to weight, but it's pretty fantastic stuff. There's a lot of cool composites out there. And I plan on using a whole bunch of different ones to make stuff in the future. I'm not just going to be a composite channel now, though. I mean, that's what this video is about, which is why that's what I'm talking about. But I can use all these things to do lots of different projects. So it's going to be integrated into different projects, because I feel like the coolest thing to do is to take all of these different things that I learn and use them to make projects better, instead of just making something out of one material. If you can integrate all the different stuff that you know, I feel like that makes projects interesting and probably makes it turn out better. Anything else?
How's the Aquaman project going?
The Aquaman project is actually going pretty well. I don't really want to talk about it because I want people to be surprised, but yeah, it's going pretty well. It's just, it's extremely time consuming. It's a lot of CAD work. It's testing, and it's just, you know, I can spend 16 hours in a day doing a bunch of stuff for it and have zero content to put in a video unless I just do like 20 seconds of me being frustrated sitting at the computer doing CAD work, you know, or like watching the 3D printer to make sure the print's going to come out correct. So it's just slow, you know. I don't have like a major production shop, like a huge thing to make this happen. I'm, you know, flying by the seat of my pants in my little garage with a 3D printer and an angle grinder. But huh?
Somebody commented, wanted to know if you could pronounce their name.
I would say it's Kaled Reader. Is that correct? It's going to take a while because there's lag.
Yeah.
That is correct.
There's also a question on if you've tried anything with Kevlar.
I have, actually. Get up. Stay there. I had this stool, and it was broken. The seat was ABS plastic, and it cracked in half. And I'm not really sure why the resin is starting to turn white, but this was another experiment to get better at using composites. But I got a mixed batch of stuff from Composite Envisions, which is where I get all my stuff. Not sponsored, hope they do. And it came with a roll of blue Kevlar / carbon fiber. So I did 2 strength layers of scraps of carbon fiber underneath of this, and then I did 2 layers of this turned, or no, maybe it was just 1 layer on top. Either way, more than strong enough for you to sit on. But Kevlar is an absolute nightmare to cut. Absolutely terrible. I had to use metal shears to get through it. I had scissors that were supposed to be for high-end stuff like this. They didn't specifically say Kevlar, and yeah, they wouldn't cut it. It made them dull, and I had to get them sharpened. Instantly, immediately. I tried to use them 1 time to cut it, and it ruined them. So if you're going to cut Kevlar, make sure you have Kevlar rated shears specifically. Otherwise, you'll ruin your scissors immediately.
You got a thumbs up on the pronunciation.
Sweet.
Also, any plans for selling or giving away any swords, a giveaway or any for sale?
Possibly. I'm selling the Buster swords right now. I'm batch building them, so I will have some for sale that are ready instead of having to build them as the orders come in. But I have some that are priorities that I'm working to finish first before I worry about getting the rest of them made. So I'd say it'll be a little bit till all of them are done, but I have a couple that are getting closer now. So yeah, I'm selling Busters.
Mark Canote wants you to test a Kevlar panel with the Canon. I'm assuming he means the...
Oh, yeah, the broadsider.
Yes.
Yeah, that's a good idea. Maybe, yeah, it'll be Will It Broadsider Kevlar Edition. That's what I'll call the video. That's a great idea. I'm definitely going to do that. That's a nice short video, and it'll be cool. Anything else? I'm getting real irritated with flies in here, so this live stream's about done. Nope? Alright. Thanks for watching. Hope you enjoyed it. I will see you guys in the next video, hopefully very soon.